So this is exercise 79, page 168, question number 1. We've got to find the mass of this hemispherical copper container, given that the outer radius is 12 centimeters, the inner radius is 10 centimeters, and although it says in the text 1 cubic centimeter of copper weighs 8.9 grams, what it should say is 1 cubic centimeter of copper has a mass of 8.9 grams. In other words, the density of copper, which is what I've written here, the density using that symbol for density rho, and then subscript Cu, which is the chemical symbol for copper. So the density of copper is 8.9 grams per cubic centimeter. So actually what we're doing is we're using the formula that relates density, mass, and volume. Density is mass over volume, which you should know. Rearranging that for mass, it's density times volume. So we need to find the volume of this container, multiply that by the density, and then we've got the mass. So to find the volume, well, we need the volume of a sphere. The formula for the volume of a sphere is 4/3 pi r cubed. So we could find the volume of the outer sphere, the volume of the inner sphere, take one away from the other, half that because it's a hemisphere, and then we've got the volume. However, algebraically we can simplify things slightly, so it's worth thinking about this as the mathematics part of it. So if the volume of a whole sphere is that, then the volume of a hemisphere is a half of 4/3 pi r cubed. But a half times 4/3, multiplying top 4 1 to 4 and the bottom 2 3 to 6, we get the volume is actually 4/6 of pi r cubed. But of course that reduces down to 2/3, so actually the volume of a hemisphere is 2/3 pi r cubed. So that's the first thing. Now to get the volume of this hemisphere, we need to consider that the total volume equals the volume of the outer hemisphere minus the volume of the inner hemisphere. So we can write that that means that the total volume equals the volume of the outer sphere, which is 2/3 pi times the radius of the outer cylinder cubed, minus 2/3 times pi times the radius of the inner hemisphere cubed. And we can see hopefully now that actually keeping it in terms of symbols means we can factorize, because 2/3 pi can come outside a bracket and we're left with the outer radius cubed minus the inner radius cubed. So we can now use that formula to find the volume. And that just speeds things up a little bit, and more than that actually, it means we can do this in one hit on the calculator, and that helps with accuracy. You hold in the accuracy all the way through, and then you could just round your answer at the end. So that's a very good way of attempting to do the problem. Try and get the formula in the correct form before we put the figures in. Okay, so see if you can now complete the question.